Friends, computer science is ever evolving. The new kid on the block is a digital twin. Interesting, isn't it? What does this twin do? It's a virtual replica or representation of a physical form, physical object, a system, or a process. It fuses artificial intelligence, AI, the Internet of Things, IoT, metaverse, and augmented reality to create digital models of real world objects, systems, or processes. Let's understand this and see if we can create clones of ourselves this Saturday. So here we go. Friends, digital twins are mirrors. They mirror the characteristics, behavior, and attributes of the real world counterpart in real time using data and sensor inputs from the physical objects to simulate and mimic its behavior, enabling analysis, monitoring, and predictive capabilities. They can also be virtual copies of buildings, manufacturing plants, cities, and virtually anything. What does one gain by doing this, you may ask? Now, the organizations can gain valuable insights into the performance, maintenance, and optimization of physical entities. That's the advantage. There's an interesting story involving a virtual assistant that can tell us more about the digital twin. Some 5 years ago, an AI-powered chatbot named Tay, was introduced, on Twitter by Microsoft. It was designed to engage in conversations with users and learn from their interactions to improve its responses. That experiment, however, took an unexpected turn when trolls and users deliberately asked Tay some inappropriate and offensive questions, causing it to give out offensive and controversial tweets. It soon spiraled out of control when it began tweeting racist, sexist, and inflammatory statements. The result was that Microsoft had to shut down Tay within 24 hours to prevent further damage. What is the lesson in it for us? Beware the potential risks and challenges associated with AI-based virtual assistants. In fact, ChatGPT would politely tell you that it's not within its means to reply to controversial questions now. The natural language processing is there for you. It's important to carefully manage and train them to avoid unintended consequences that are both moral and ethical. Now, digital twins too are similar, right? Digital twins find applications across industries such as manufacturing, healthcare, transportation, energy, urban planning, you name it, offering benefits such as predictive maintenance, improved operational efficiency, enhanced product design and development, and better decision making based on real-time data and simulations. Of course, the data comes from the sensors or the IoT devices. If digital twin is a virtual replica of a physical object or system, can we create a virtual replica of ourselves? If God made the original, why can't we make a copy? However, it is currently work in progress. Maybe it will come at us in a few years' time. Creating a digital twin of a human being will need data such as medical records, genetic information, measurements such as heart rate, blood pressure, CT or MRI scans, and so on. Such data is then integrated and organized into a cohesive model, creating a computational model based on mathematical equations, algorithms, or machine learning techniques that represent human body is the next step. The model will then simulate the behavior of the human being. Validation is against the real world observations from wearable sensors like your watch, IoT devices, various sensors across the world, or other monitoring devices. An iterative process that allows refinement and optimization of the model will eventually create a digital twin of what? Of ourselves. The whole thing is in the making, and we will probably see that in a few years' time. While there are instances of creating digital representations of human organ models of physiological simulations, creating an accurate digital twin of a human being is extremely challenging. It would require capturing and integrating massive amount of data from multiple sources. Digital twin is healthcare for human beings is extremely promising. Personalized medicine, predicting disease risks, optimizing treatment plans, simulating the effects of different interventions, medications, disease prevention, early detection, health monitoring, wellness management, predictive analytics, proactive healthcare, virtual clinical trials, medical education, training, remote healthcare, telemedicine, simulating drug responses, surgical procedures, or disease progression to assess the personalized treatment plans are all possible, and some of that is already happening. They rely on data-driven algorithms and computational simulations to approximate the behavior of specific aspect of the human beings. The EU-funded NeuroTwin project aims to simulate specific human brains in order to build models that can predict the best treatment for conditions such as Alzheimer's and epilepsy. One notable example, of digital twin in entertainment is its utilization in the field of visual effects or VFX and animation. Interesting. Human psychology is dynamic in nature, and human mind is highly complex. Though creating a real-time digital twin of a human being is significantly distant, some ethical concerns like privacy, data ownership, and consent must be addressed. Friends, of course, the ultimate vision of the digital twin is to create, test, and build any equipment in a virtual environment, including ourselves. Only when we get it to where it performs to our requirements do we physically manufacture it. That's the day we would all be waiting to see, though there are multiple implications when that happens. With that, friends, let me end this Saturday's episode with a promise to be back the next Saturday with another episode that I think you will find equally interesting. Until then, thank you. Dhanyawad and Namaskar.